Hi folks, today I'm going to teach you how to do the 35s. As you can see at the top of the 35s, there are some answers to several problems. And it also says circle the neutralization step in each of these factor labeled problems. Today we're going to be using the mole map off of your cover, and we're going to be using the grams. That's what makes these problems just a little bit more complicated. So in this very first problem that you have to do, it says that we have 3.79 grams of barium hydroxide. They give us the molar mass of 171.33 grams per mole. It was titrated or neutralized with 2.2 molar acetic acid. Acetic acid can be written two different ways. Personally, I prefer the first version because the hydrogen's out in front. It's very easy to identify as an acid. The second version is the organic way of writing it. It asks how many milliliters of this monoprotic acid, meaning it's only got one hydrogen that it's going to give up, will it take to neutralize the base. Circle the neutralization step and don't start with what you're trying to solve for. So I'm trying to find out how many milliliters of acid I need. And that's not what I'm going to start with. So that means I'm going to start with my grams of barium hydroxide. So what did they do here? They took a beaker, they threw some powder into it, the barium hydroxide powder. They grabbed a burette, and they started putting some acetic acid inside of it until we reached neutralization. So in this problem, we're going to start with grams of our base. We're going to go to moles of our base. We're going to go to moles of hydroxide ion, moles of hydrogen ion, moles of acid, liters of acid, and then we're going to take that over to milliliters of acid. So that is the pathway that we will follow with this problem. So here we go. So I'm going to start with 3.79 grams of barium hydroxide. Multiplication sign, division bar. Grams of barium hydroxide are on top, so grams of barium hydroxide go on the bottom. Grams of barium hydroxide, if you're on Gram Island, the only place you can go to is Mole Island. So this is going to be moles of barium hydroxide. Whatever's on top goes on the bottom of the next step. Moles of barium hydroxide. When you're on Mole Island, the only place you can go, which would make sense in this one, is to moles of hydroxide ion. So moles of OH. Okay, we're going to do a little continuation off that side. Come in over here. So moles of OH are on top, so moles of OH go on the bottom. When you're on moles of hydroxide ion, the only place that makes sense to go is to moles of acid, which would be the hydrogen ion. So moles of hydrogen ion, island. Multiplication sign. Moles of hydrogen ion go on the bottom. Moles of hydrogen ion, we're going to go up to moles of our acid. So this is going to be moles, and this is going to be our acetic acid. So that's that HC2H3O2. Then in this problem, we're trying to find milliliters of this acid. So whatever label's on top goes on the bottom. Moles of HC2H3O2 up to liters of HC2H3O2. One more step. Liters of acetic acid, HC2H3O2, 2 milliliters of HC2H3O2. There we are. Now we got to put some numbers in. So we go back up to the top. We have moles over grams. That is our molar mass, so that is 171.33 grams in 1 mole. We go to our next step. How many OHs are in 1 BaOH2? Well, there are 2 moles of hydroxide ion in every 1 mole of barium hydroxide. We go to our neutralization step, so we'll circle that. You need to have this step in all of your problems. So that it's always a 1-to-1 because the hydrogen ions and the hydroxide ions balance each other out. I realized right here I forgot to put a plus. Apologize for that. How many hydrogens are in 1 mole of acetic acid? Well, this is where they told us that this is a monoprotic acid. So there's 1 mole of hydrogen in 1 mole of acetic acid. Yes, I know there are 4 total hydrogens, but only 1 is actually given up in an acid-base reaction. Here I have liters and here I have moles. So I go up to the problem and it tells us our acetic acid is 2.20 molar. So that's 2.20 moles in 1 liter. As always, there are 1,000 milliliters in 1 liter. You crunch all that work, and with correct sig figs, your answer is 20.1 milliliters of acetic acid, HC2H3O2. That is the correct answer for that problem. Take a look at that. Make sure you understand it. Come in for questions if you do have questions. So your classmates worked for about 15 minutes in class on the front page, and then we all went to the back side and we did the next problem. So in this problem, it's a little bit different. We're going to calculate molar mass or grams per mole. In this problem, we're going to calculate the molar mass of an unknown monoprotic acid. The H stands for the hydrogen ion. The A stands for an ion or a negative ion. So fluoride, chloride, bromide, iodide. So we use HA when we don't know exactly what the acid is. In this problem, it took 22.2 milliliters of 0.14 molar lithium hydroxide solution to neutralize 0.44 grams of acid. That's what this problem is telling us. So what we're trying to do is we're trying to find the molar mass of the acid, and therefore we can look with a little bit of work and figure out what acid we actually have. So in this problem, again, we're trying to find grams per mole. We're always going to start with what we're not trying to find out. So we're going to start with this 22 milliliters. So we're going to start down here in this range. We're going to go from milliliter island to liter island to moles of base to moles of hydroxide to moles of hydrogen ion. We're going to get to moles of acid. And they give us the grams of acid. So at the end, in a separate problem, we'll take these grams, we'll divide it by the moles that we got there, and now we'll have the molar mass. So that is what we were trying to figure out in this problem. So in this problem, we'll start with what we're not trying to find out. So we're going to start with the 22.2 milliliters of lithium hydroxide. Make sure you're looking at the cover of your unit pack. If you want to try this problem before I go over it, go right ahead. From milliliter island, the only place I can go to is liter island, but first we got to do the next step. So milliliters up on top to milliliters on the bottom. Milliliter island to liter island. Okay. Whatever's on top goes on the bottom of the next step. Lithium, liters of lithium hydroxide. From liter island, the only place we can go to is mole island, so moles of lithium hydroxide. Whatever's on top goes on the bottom of the next step. Moles of lithium hydroxide. And when we're on that island, the only place we can go to is to moles of hydroxide island. Got to continue on over here. So whatever's on top goes on the bottom. So moles of hydroxide. Now we have to go from the base over to the acid. So this is going to go from moles of hydroxide island to moles of hydrogen island. Whatever's on top goes on the bottom of the next step. Moles of hydrogen ion to moles of our acid. And we don't know what our acid is, so that's HA. And we stop. We need the moles, and then we need the grams. We take the grams divided by the moles at the end in a separate problem, and we have our answer. So right now, let's start popping in numbers. Milliliters and liters. The relationship is 1,000 milliliters in a liter. Moles over liters, liters over moles, that is molarity. They give us that, so 0.140 moles in 1 liter. How many hydroxide ions are in a lithium hydroxide? Well, there are 1 mole of hydroxide ions and 1 mole of lithium hydroxide. Next step is our neutralization step. It's always 1-to-1. This is where we are neutralizing something, and we circle it. Always needs to be in your problems. And then in the last one, how many hydrogen ions are in our monoprotic acid, meaning there is 1 hydrogen ion in 1 mole of HA. I do all this math with the correct sig figs, and I get 0.00311 moles of HA. Now, I'm not done yet. It wants to know molar mass, which is grams per mole. In the problem, it gives us our grams right here. So my last step that I have to do is I have to take 0.444 grams of HA, divide that by what I just calculated, 0.00311 moles of HA. I do that math and I get 143 grams per mole for HA. Then I can go on to the periodic table, calculate some molar masses, and figure out exactly what acid I have. Your fellow students have the rest of the time to work on finishing up this page.